In this video, we're going to see how we can perform a hypothesis test about a single population mean by using Excel. So this question says, students estimate the length of 1 minute without reference to a watch or clock, and the times in seconds are listed below. Assume that a simple random sample has been selected. Use a 0.05 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. Does it appear that students are reasonably good at estimating 1 minute? So here's the sample data we were given. So first we need to figure out what the null and alternative hypothesis are. So if we are trying to determine this, what we want to do is look in the question for something about what our claim is. So that was right here. It said test the claim that the times are from a population with a mean equal to 60 seconds. So we know we're doing a test about a mean, and we know that the claim is that the mean is equal to 60 seconds. So how do we fill this out? Well, first of all, this is a mean, so the appropriate symbol to use to represent a population mean is a mu, the Greek letter mu. As far as what goes here, remember the null hypothesis always has an equal sign in it. No matter what, it always should have an equal sign in it. And here, the claim was that the times were from a population with a mean equal to 60 seconds. So since we have to have an equal sign here, the claim is going to go here in our null hypothesis for this example. Sometimes the claim ends up being in the null hypothesis if the claim is that the parameter is equal to something, and sometimes it winds up being in the alternative hypothesis if the claim is that the parameter is more or less or not equal to something. So since the claim is that the mean is equal to 60, then the alternative would be that it's not equal to 60. So we would choose not equal to 60 in this case. So first we need to identify the test statistic. So we can do this in Excel, and we're going to have to do this kind of by hand. We're going to build the test statistic ourselves based on the information we were given. So first we need to build this formula right here. X bar minus mu x divided by s over the square root of n. So what do all those mean? X bar is the mean from the sample. Mu x bar is the mean in our claim. S is the standard deviation of the sample, and n is the size of the sample. So in this question, we remember that we were given actually raw data. Sometimes those values we just talked about will just be given to you directly in the question, and you can just plug them straight in. But in this case, we were given the raw data, and we didn't get those values, so we need to find them. So we can find them by clicking on the little blue icon right here and saying Open in Excel. So here's the data that we were given. So first we need to find these values. We need to find X bar, that's the sample mean, and we need to find S, the sample standard deviation, and we need to know how large this sample was. How many numbers were there in the sample? So let's do that. So the first thing will be our X bar. So X bar is the mean. So remember the mean we learned how to find earlier. We can do that by going to formulas, more functions, statistical, and the name of the formula for a sample mean is called average. So we're going to click on average, and then we're just going to go highlight the numbers that were in our sample and click OK. So this number right here is the sample mean for the sample we were given. So next we need the standard deviation. To find that, we go to the formulas, more functions, statistical, and we're going to go all the way down to the S section. And we are going to grab this one, stdev.s. That means standard deviation of a sample. Same thing, once this box opens, we're going to go highlight the numbers in the sample and then click OK. So now we have the standard deviation. And finally, we need the sample size. So you can either just count, like I can see here very clearly that there are 15 numbers in this sample because I start at row 1 and it ends at row 15. But if we couldn't do that, or if it wasn't so easy, we can go to formulas, more functions, statistical, and go to count. Same thing, we just go highlight the values in our sample, and it will count up how many values there were in the sample. So 15 in this case. Now that we have all of those, we're ready to find our test statistic. So we're going to do that by building a formula that looks like this, where we take the sample mean, subtract the mean in the claim, divide by the standard deviation over the square root of the sample size. So any formula we do in Excel, we start with an equal sign. And we're going to start with parentheses here because we want to put that whole numerator into parentheses so that Excel does the order of operations in the correct order. So X bar was this number right here. So you can just click on it and Excel will bring the cell number into the formula. And it'll know then to use that number that's in that cell when it computes the value. Minus, remember the population mean, the mean in the claim, was 60, right? That was the number right here that we had in our claim to begin with. So minus 60. Close the parentheses to close off the numerator. Now we're going to divide that by the standard deviation over the square root of n. Now it's important that you also put parentheses around this denominator, otherwise the order of operations will be wrong and you will get the wrong result. So make sure you put parentheses around both the numerator and the denominator when you build this formula. So we're going to do the standard deviation, which was right here. And we're going to divide that by the square root of the sample size. To do a square root, you type SQRT and then open parentheses. We want the square root of the sample size, which one's right here. And then we're going to close two parentheses, once for the square root function and once for that denominator. So there's our formula. We hit enter. So our test statistic is 0.571, etc., etc. Going back to our problem, we were supposed to round the test statistic to 2 decimal places. So right now we have a whole lot more than that, but if we want to shrink it, we can either do it in our heads or we can go up to the Home tab and then come over here to these buttons. These will let us increase or decrease the number of places after the decimal point. This one will decrease, so we're going to decrease this down to 2. So 0.57 is the test statistic rounded to 2 decimal places. So now we need to get the p-value. So to get the p-value, we're going to use one of these 3 functions, and it depends on if our test was a left-tailed, a right-tailed, or a two-tailed test. If it's a left-tailed test, we will use the function t.dist. If it's a right-tailed function, we use t.dist.rt. RT means right. And if it's a two-tailed test, we use t.dist.2t. So looking back, our alternative hypothesis is what tells us what kind of test we're going to have. If the value of the operator here in the alternative hypothesis is a not equal to, then that means we have a two-tailed test, because we don't know if the value in this statement means that the mean is less than 60 or more than 60. It could be either one. We just know it's not equal to 60. So less or more means 2 potential tails, so this is a two-tailed test. Since this is a two-tailed test for our p-value, we're going to go find the t.dist.2t. Again, that's under formulas, more functions, statistical, all the way down to the t section. And we see it right here, t.dist.2t. So the first thing it wants to know is the x value. The x value is the test statistic. So we're just going to click here on the cell that had the test statistic in it. The degrees of freedom is the sample size minus 1. So the sample size was right here, so we can click on that, and then we just subtract 1 from it like so. And we hit OK. So our p-value is 0.576579. That's probably too many decimal places. Yep, it sure is. So this wanted us to round to 3 decimal places. So again, we can go to the Home tab and click on this button right here to reduce that number of decimal places to the number that we wanted. So the p-value is 0.577. So now we need to make a conclusion based on the results we just got. So the p-value here was 0.577. Remember, the way we make our conclusion is we're going to compare that p-value to our significance level, which was given in the question. They told us that for this question, we're going to use a significance level of 0.05. So the rule is, if the p-value is less than the significance level, you will reject H0, reject the null hypothesis. If the p-value is more than the significance level, then you will fail to reject the null hypothesis. So in this case, our p-value was a lot bigger than our significance level, quite a bit bigger. So we should fail to reject the null hypothesis. So this first drop down here, we're going to fail to reject the null hypothesis. If we remember what we said earlier, in this example, the null hypothesis had our claim in it. So this is the statement that represented our claim. And we just decided not to reject that statement. In other words, we said we don't have any evidence that's strong enough to tell us that we should reject this statement. So what we would say here is, we would say there is not evidence at the 0.05 significance level to warrant rejection of the claim that the times are from a population with a mean equal to 60 seconds. So on this basis, it appears that as a group, the students are reasonably good at estimating 1 minute.